Hi there. I've been meaning to do another video for some time now. To do another programming video for some time now, and well, now here it is. And today I'm not going to do compiler programming, which is first. Because what I'm going to do is I'm going to work on a project to ease my suffering that I have with this NFS share that I'm currently working on. So I'm written a little program called micro NFS. Or rather, micro NFS is supposed to be a library. Basically, it implements the RPC mechanism that the network file system depends upon. It's really not that hard. It's just you serialize a bunch of data, and in this case, it is the data that's being sent to the file system. So read year, write file, read file, change year, these kinds of things. And well, that's that basically. So I've just finished the ability to get a listing of what's on the NFS share. Like you can see these DT, HackerRank, OSM root. If I list what's on my mount git on my NFS share, you will see that there is a dt3.png, for example, and if I show you how much bytes it takes, it's here. That's exactly the same number that I get reported from my ls, from my tool nsf. So here's the source code for nsfls. It's 700 lines, but that's because I haven't yet cleaned it all up. Essentially, getting your connection to an NFS server requires a couple of steps. So first you have to talk to a so-called port map server to get the port for the services. And you first ask for the mount server that will tell your network file server, well, basically you authenticate yourself against the mount, then you get a file ID back, and with that file ID you can then do a directory listing, and that file ID will be the root of whatever exported directory you are mounting. So you can see here I am doing this empty mount for NFS git, and then I print the file handle, and that is that. And if I were to mount some other thing that perhaps doesn't exist, then you would see this would fail. Like here you see the file handle that comes back is all 0, and we have a status NFS error bad handle. So it only works when you list a directory that actually exists. And I should probably make this a command line parameter parameter, right? But then again, who cares actually? It's not like this program has to be like fully fleshed out, because it's just a test for my thing that that is able to interact with the file system. So the only call I've implemented so far is the ones that will establish the connection using the port mapper and such, and the reader and reader plus. But essentially what you want always is the reader plus, because the reader itself doesn't tell you whether it essentially just gives you file names that you then have to query using lookup calls, and essentially there's no point in doing that. The better option is to call your reader plus, and that will tell you for every directory you get how much. Now I lost my train of thought. Whether the names, the directory and such, like all that stuff is tagged on, which means you have like 124 bytes per file, more than you would have if you were just getting the names. But it's still better than issuing lookup call after lookup call after lookup call to check out whether the file you are getting is the one you actually want. So now that we can get a reading, now that we can get a directory listing, and we can get that in a callback, and be sure those pointers are only borrowed, don't keep references to them. They are local buffers on the stack, they're not stored anywhere. So if you want to use the information that's in there, you have to do that during the callback. And if you want to store them, you have to copy it out. Essentially, that's that. And yes, I'm thinking about whether I should give this this callback that gets the file name as a const char, whether I should give it the length of the file name, since I do have that, or whether I should just use the zero terminated form. For now, I guess zero terminated will suffice, since the fuse file system that I'm going to write, the API can't take counted strings. It can also just take zero terminated strings. So I guess what I want is to implement the read call as well, and maybe the write call. And once I have read write redir and make file. I can export those, but the first thing that I do have to do for sure to get like my file system connection is the read call. So luckily I have the handy RFC. NFS RFCs 1813. RFC 1813, and I want the read. Function called read3. Read3 proc. There it is. It takes a file handle and offset and a count. And the thing that I always have to look up is whether the offset is 64-bit or 32-bit. I think it's 64-bit. Well, maybe I don't even have to look it up. Maybe I have it as in my structure NFS micro NFS dot h may have it. Offset 3, yes, it's a 64-bit and this size as well. All right, that's unfortunate, but oh well. Right, let's do that. NFS read. It takes an NFS connection. Maybe I should call this socket. And then it takes a file handle, which is a const f handle star file. And account. Maybe I wanna put those. I keep it as is right now, which is technically a 64-bit number. Oh well. Which then should return, I guess, a 64-bit count as well. And there is -1 in case it failed. And if I want it to be smarty pants, I could have these things return error numbers, the same as Fuse does, and have like an out parameter for the size. I actually think that's a good idea. Like, I give it a pointer to the count I'm willing to support, and it gives me the count that I actually read. Well, I can still do that later. For now, I just wanna get this thing up and running. So what I do is I make an RPC serializer, which I need to initialize the RPC call. Then the RPC call will set a random transfer ID, read transfer ID in this case. I want to do an NFS and I want to do the read procedure. That one. And I don't have a define for that yet, but that is number 6, as we can see in this RFC. So what we do is, I'm not sure if I have a jump to mark or not, but I can just do read dir procedure. Then I get to where all the defines are. Do the define NFS read to see if it's spelled correctly, or at least spelled as correctly as all the others. 6. Well, while I'm at this, which are the other ones that I want to do? I think write and make notes. Remove access for now, I don't, but write I certainly want. Look up and get attributes. For now, I don't need that. Create and make dir. Well, I might want to have create, which is 8, right? Create. And make dir. For now I don't need it. So let's go back to read 3 and also like read proc. There we go. I think I'm indented one level too much. And then, alright, the first thing I want to push is the file, which I should have a function for. It should be called RPC serializer. Serializer push, file handle push. Oh, I don't have a file handle. I don't have a push file handle because I use the push string call instead, which does the same thing essentially. Right, that will work just fine. I just have to determine the length of the handle. So I do file, I think a file handle size, something like that. File handle size. Well, they wouldn't be in this file. They would be in RPC serializer, perhaps. Size. File F handle. I just look for F handle. I have a read file handle. but I don't have a right file handle. At least not in here. That's weird. There is a way to file handle size, handle length. F handle 3 length. That's the ticket. That's how you push file handles. Makes me wonder how reader plus pushes its file handle. Oh, here. Has it right here. Yeah, that is how you do it. That's not here. Let's file. Let's file. I guess we could assert it's not null, but who is gonna use a null file handle? And I mean, when we're taking the length, we will already see that, so it won't fail deep down somewhere if it's null, so you don't have to put the assert in. Yes, now I push. Do not serializer push. I don't have push 264 yet, but I will. And I just push the offset. And then I push the count. And there you can see that I forgot it. During 614 set, count. Yeah, that's that. Now that we have pushed the arguments on, we have to finalize the FPC serializer. And then we send it off the socket that we got parsed in. Send and NFS scripper. So that's it for sending the read request. Now we have to do the deserialization that goes like this. This is all the boilerplate involved with deserialization. Like that. Then we'll factor these into functions once I'm comfortable with how I want to do that. Also, this finalize and send you could trivially put together. Yes, that you could put together because you always want to finalize before sending. I wanted to put them into separate steps while I was still working on the protocol, so I could inspect the packet before sending it out. But it turns out if you use tools like Wireshark, actually sending out the packet gives it to you in a nicer form that's easier to inspect. And right, now we are dealing with the result. So the result is predicated on the status. And in case of a read, it can actually easily fail. So I do want to field that. So I say if status doesn't equal NFS 3, okay, which is status, which is 0. So you can just do that. If there is a status, then print stdio hello while reading sm error sent as while reading this file, and then we do NFS status characters status comma let's just do it like that, and a comma and the file name. Well, I don't technically have the file name. Perhaps I should have a read call the text, the file name. That could then well, I could do a lookup in my own cache on the handle. How about that? Yeah, I think that's what I'm going to do. So, but I'm not going to implement it right this second. So, while reading that, then for the future, it's like lookup name and cache file. But for now, it's just not. There we go. Okay. That is if it fails. The other thing, if it fails, what we get is a read result fail, which gives you the file attributes of whatever you try to read. Because maybe you try to read a directory and then you could see that it is a directory. However, right now I don't particularly care about the failure case, so that would be that. Let's just return -1 because it couldn't read any byte, and then we are done with the failure case. We now know that we are not in the failure case because the status is 0, which is the same as NSF OK. NFS OK. Right. Yes, that is... Okay, if it's 0, it succeeds. Must be less than or equal to the value of RT max in the FS info reply structure. It contains a file of grandson return only RT max bytes, resulting in a short read. Does it return how much it actually read? Okay. That is that are to be read. So that's the parameters. Number of bytes actually returned by the read are returned. So that means if the read ended at the end of file, right, it may return EOF even if I didn't read the whole file. Like if I issued a request which it couldn't send me all the bytes for because the window wasn't big enough, I may get an EOF without having read the file if I specify a count that's too large. That's the issue. That ain't gonna happen for now, but it's good to keep in mind. So, to do, fix me, make sure size is less than RT max from, what's the name of the query? NFS info. NFS info query like that. Okay. Okay. And data is simply the binary data that's there, and that, by the way, is a counted array. So first comes the size, and then come the bytes, and they're padded to be a multiple of 4, since this RC protocol can only work with 32-bit instances, which makes it easy to handle actually with all the byte swapping and stuff. You only need a 32-bit swap, you don't need a 16-bit swap. since you never really deal with 16-bit quantities. Okay. Then we have read the status. Then now it's time to read the first bit in the file attributes. Those are post-op attributes, which means that they are optional. They may not be there. They should be there most of the time, but they may not be. And they will be preceded by a 4-byte integer that's 0 if it's not there. So what we can do is simply if rpcd serializer dash read u32. I have a read bool, but I'm going to get rid of it. Address of the deserializer. If it doesn't equal 0, it's a non-zero byte, then if it's a non-zero uint, then we want to read the attributes. And for now, we simply discard them. rpcd serializer read file handle, no, not string, file attributes. We read them, we discard them. And now we want to read the count, which is a 64-bit value, so 64 bits. Count equals rpcd serializer read u32. Read u64. There it is. There we go. That's how big our read is. Which technically we wouldn't need since we have it in the counted data. Then we read the EUF equals D equals 0. And then we read in the data, for which I don't think we have a call. And also, we now need to provide a containment for where we want to store the thing. So the read call has to send us a buffer in which we are to store this. Let me quickly look at, I think we are done with that. After that, yes. Alright, then I can quickly look at console, don't override it. And how the read call does it. So the regular read call takes the file handle, then it takes the place where we want to fill it in, and I think I want to do it the same way. Just a little OCDness here. Nothing to worry about. So we have a event to star data, and that is where we want the results to be put. Okay, then essentially have a while count minus. Well, technically we have already received the bit of data in the network request. So what we can do is we can do a mem copy directly from here. I mean, first we have to, since this in the RFC, you can see that this is a counted array. So we first have to read the array size. That's a 32-bit number. Which makes me wonder why we would have a 64-bit count. But apparently it is a 64-bit. Let me quickly search for that, just so I can be sure. Oh no, it's a 32-bit count, so my header is off. Oh, it's offset 3, that's a 32-bit thing. It's size 3. Let me quickly add count, just in case I need it. Yes, I was quite surprised that you would do a 64-bit offset when you can't store you would do a 64-bit count when you can't store that. So that means that the second read, right, that the second parameter to the read, which is the count, is not a 64-bit count at all. It's a 32-bit count. And maybe I give it these type names, just so. Nah, let's not, because I want users of the API to be able to actually read it. Offset can be 64-bit, of course, but the count can only be 32-bit. And I'm not quite sure if I should put the offset last. I mean, that's not how it's done in the proc, but that is how I want to do that in the API, I think. And I think I want to put the handle. That's a good question. Should the handle go at the very last position? No, I think it's good where it is, but the offset should go last. I think that's the thing. Because more often than not, it's going to be 0, and you just add a 0 at the end. I think that's how it should be. Now, what can happen, and most likely will happen, that your read request does not fit into one transfer. So the TCP stream underlying this will give you a virtually infinite stream of data, but your buffer that you use to store this thing locally might not be enough to store all of that data. So one thing, well, I can do is to have a while loop in there such that when my received data is less than my actual data, and by the way, this exit is called the read exit. When it's less than my actual data, then I want to to RPCD serializer. Then I want to loop and receive more of that data. So first I get the array size, then I do ensure RPCD serializer ensure size. So usually I would use an ensure size call that makes sure that I have all of the data. However, I can't really do that. So I guess I could do a while loop, and I just use while. Let's use the array size. Well, array size. So during the first read, I will have however much is currently left in my buffer. So buffer left equals RPCD serializer buffer left. This is how many bytes I have left in my buffer after reading the size. So these are all bytes filled with data plus padding. If the buffer left is greater than or equal to how many bytes I have in the array, then I don't have to do anything. All I do now is a mem copy and I'm done, and else I have to loop. But blah blah blah. Right. For now I just said that that doesn't happen, because I don't want to deal with that case right now. And if that is the case, all I do is a mem copy. Forgot how I called the data, right? Yeah, I copy from data to I copy to data from my current buffer position. That would be self read pointer read pointer, and I take however many there are on the array, and then I return I guess I can return count. Because count should always be the number of what I've read. Okay. That should do reading. So let's see. Let me look if I have a nice file in my NFS share that I would wanna grab. How about ll.txt? Alright, we can, that will fit into the buffer for sure. Read so what I have to do for this is I have to make a special callback that uses my read dir with the appropriate comparator set. And here it is a real bummer that the callback does not allow you to put your own Well, it could, right? I mean, I'm writing the signature for the callback, so I can certainly have it have the void pointer user maybe like this. Void star user data. Right, that would work. And that I would then put after the call like that. And then whenever I call the callback, callback, where is the place where I call the callback? Here's the place where I call the callback. It gets the user data pointer. And then I can do my callback, print the name, and right, I can do void star user data, and I just assume that this is gonna be the search struct, which I'm going to define right now. Struct search struct, which has a handle 3 if it finds the result handle, and but that's empty, that's not going to be filled out by the user. Const call star 9. It's just gonna search your team. It's just gonna have the name, and if the name is there, I just put the file handle in, and that is that. Again, this pointer will not persist, so I have to copy it as a value in there, but that's no issue. So my callback, I'm just gonna keep this non-descriptive name and this printing out. I'm maybe gonna maybe not such a non-descriptive name. Excuse me. Maybe not such a non-descriptive name. Maybe I'll just search dear, search dear CB, like that. That's gonna, so first there's gonna put the search dear T star data search dear T star search requests equals search dear T star user data, so just cast it here, and then I can do if the search dear, if the search request name strike It's not called stirrec, what's stircomp? Search tier request name equals the file name that I get here, and then you return 0 because the search can now stop. This is why you have, when you have iteration callbacks, you always have a return value that tells you, that tells the iterator function if the iterator function can stop or not. That just makes it much easier. So, because then you can do early exits, whereas otherwise you couldn't do them. So if it's 9, we return 0 to stop iteration, and we store the handle in the result. So first we assert that we have a handle, and then we do search requests, result handle equals star handle. And we return 0. In the case where we didn't find anything, the 0 handle with which the search starts should be in there. So now we can do read here and see where we call it. Here is where we call read your plus. We now call it like search your callback, and we then give it the address of our search data. Then if search data dot handle does not equal if it's not equal to the 0 handle, or like, how do I guess I will have to write a comparison function. It will not do a strap compare for me. Okay. I can just do mem compare myself. So if memconf search result dot handle well, I could just sum all the bytes in the handle, and if there are 0, if I do a 64-bit sum, then that should be fine, I guess. It's kind of really bad, but that's what I'm going to do now. So yeah. if handle sum search result dot handle. So if it is a zero handle, there will not be handle sum. Well, yeah. If there is a handle sum, then I want you to issue a read on the handle. NFS read. And I already forgot the so first comes the socket, then comes a pointer to the handle, search result handle, by the way we can create one of those, search duty search result equals 0. And then I fill in the name. So what was the name of the file that we wanted? I think ll.txt. So yeah, that is what I want to search for. I pass that thing out. If it is being found, I want the handle to be printed. Print file handle search result dot handle. Was a result handle? I think it was result handle. And let me implement the handle sum jump. Also just gonna do here quickly the t handle sum of handle star for and I equals 0 and I less than handle length handle this const 0 and 32 sum starts out as empty. Sum plus equals handle dot think handle. It might be handle 3. Let me read this up. Control R, Alt F, which then lets me read the macro. And then I have to remember where the handle is defined. It might be in micro NFS H. Here it's f handle 3, the data. So there we go. and we return the sum. No big deal, and if the sum is 0, we can be quite sure that it's not a valid handle. Okay, let's see if this compiles. I'm sure it will not. Okay. That's a point. This as well, so here. And the semicolon after definition, and I think that should be that. I can't find the fondle because it's called handle fondle. And I plus plus here. And so this shouldn't fail. I wonder why it does. Does it complain about getting a 0? Oh, do I have 2 commas? Yeah. One following and one going there. It complains about the 0 being there because it doesn't see that that can be a valid string, which can't be 467. Oh, that's the read count. Result count. So I'm going to return here. So if I'm declaring 467. I don't see where self is being used in here at all. Okay, I don't have a push U64, I have to program that. And an NFS LS 467. It complains about me using a self-read pointer, which is true, I guess. That should be the read pointer. user data as an incomplete type. That's true. It should be a void pointer, not a void. Invalid argument type. RPC is to realize or alright. Okay. Now I just have to implement the push. U64 in the RPC serializer file. Push U32. I have the push U32. So I just take that. Oh, that one is in the header. Push U32. Static inline. Because it happens so often. Well, the push U64 is not going to happen as often, so I can put that to the C file. Directly under pushing the string 64, it ensures it has 8, and then we could do a long version of that. But so when we push a value in big endian, even though it's called big endian as if it would end with the big part of the number, it actually starts with a high part of the number and it ends with a low part of the number. That's just how it is. So what you have to do is you have to swap. If you're writing two 32-bit halves, you have to swap those around, and then you write them high, swapped high first, then swapped low, right? So if I just take the high bits by shifting them out and swap those around, and then I take the low bits by masking them out like that, and I swap them in my H2 network long macro, and I just write them out like that. Well, right. So can't use the plus when I have the cast in there. Wait, is the right pointer? Yeah, I think the right pointer is a uint. Yeah, there it is. I cast two uints to get my right pointer. So it's a uint. It's a uint 8. So I cast to uint 32 to write the 32-bit value. I increase it by 4 because it's a byte-sized pointer, and I just wrote 4 bytes. Then I write the low half next. So write the high half by shifting down the value, write the low half, increase the pointers, increase the size, and that is that. And now all I have to do is take this thingy. It's not a static inline, it's a regular function. And it gets its prototype added to like push 32. Alright, I added it above string, I believe. So that's what I'm gonna add it here in the header file. And that is that. And now I believe our program should build, and maybe it will even run, but I'm not sure at all. Okay, so we get a file handle, and then we assert ingredient plus. And that seems to have happened reliably. So that looks like a root file handle, as you can see by the zeros here. We get a status that it's okay. So we did get a correct file handle. The question is, why are we dying now? 5, 2, 4. Oh, yes. I can already see why. Let's go into that. See, the problem is that we abort our iteration. Plus. The issue is essentially, it's here. The place where the file iterator can break. When that break happens, what will happen is we go out of this while loop. We write the last cookie we have, and then we write a Boolean value that tells us whether we should continue or not. Right? Because that reads the EOF. If that is not a 0, then wait, let me think about this again. So what should happen is that we read the EOF, and if that is not a 1, we continue reading. Let me quickly pull up the results here. So yeah, that's the EOF that I'm talking about. It comes after the entries over which we're iterating here. And I want the meaning of the EOF. True if the last member. So, right. I'm returning true if we should continue reading. Right. So let's return a Boolean variable like it's called should continue reading, and then we say that we set this should continue reading equal to that. However, we have a variable here that we call should continue reading such that it's there. We set it here, but what we also do is when we see we have to abort, we set should continue reading to false, and then instead of breaking we just go to return. Because otherwise we will issue this read, which we do not want to issue. Go to L return. That one will be here. L return colon. I believe that should fix the issue. Or maybe it doesn't. So let's now build us with debug info so we can see what's going on. So the head exit is something. This looks suspiciously 1D03203 like a stamp. This looks like an authorization stamp. Let me see if that is always the same. And it looks suspiciously like something else. 100-203 1D30203. That looks like two three 0010. Like that. That looks like a file handle. And I think the only thing that we have changed around this where we have the reader plus, is the callback. Like, at least I'm not aware of us changing anything else. So let me do a stash on that. And let me quickly assess whether the code we put in here was necessary for the correct operation. I don't think so. Okay, so we stash this, we build the old version, we run the old version. Let's check false. So what we had committed was needed for the correct operation. Now we fail even sooner, but we don't seg fault. Rather, we just see that the request header we get looks still not right. No, we don't have the debug information. There. Yeah, so this header is completely borked. You can see that because we are supposed to get a reply, right? However, the reply is 0. So one thing we can now do is to look at what we actually get as a reply to our reader. By using Wireshark. So just prepare a filter. So we just get NFS. Those we don't care about, but one thing we do care about is running it, going, quitting. Yes. And then we go to our Wireshark window and we stop the capture. And then there should be a redo plus somewhere. There it is. There's a redo plus call. We have exit here. We call, this is our thingy. We call with this file handle. We call again later with the same file handle, but a different cookie. So first we call with a null cookie. Here you see that this is all null. This cookie here is not all null. It's 12. and we then get a different reply. So we call this, and the first bytes after the NFS OK, we have the accept state, we have the exit, which should be 12 something. But when we start reading the exit, that's not where we are, right? And the exit we read was some complete garbage. And this must have happened in the code that we wrote. Can't have happened during the pushing. Can't have happened and handled some. It could happen. It could happen if we issue a read dear request twice, which we seem to be doing. Like, should be able to see that we issue 2 requests here and here, and the weird thing is we issue the second request after just having read 1 file, because after we put the last cookie that we got, the reply has the just has the dot file removed. So that means we just read 1 file, then we exit out, and then we read another one, and that's weird. So our function let me open Kotlin for this and sync my progress. Which goes to data session not good. No, this is the latest progress. H into my local directory, which, by the way, this is going to be taken care of by the program that I'm gonna write. And there we go. So the issue was that this flag, this return value here, is to be interpreted as a should continue reading. And for some reason, after just calling the file iter once, so the file iter if the file iter returns 0. Right? If it does not return true. Yeah, if it returns 0, then not 0 becomes true. So if it returns 0, then we store the last cookie. We set should continue reading to 0, and we return that 0. And that apparently causes us to keep reading. Because we read until there are no more entries to read. That means if the last cookie that we saw is the cookie that we started with, and that only happens when there are no more entries to read. But that's not actually what we want to do. What we want to do is if not should continue reading. And we just have Boolean here that there should continue reading equals the return value of reader plus. That doesn't fix the issue where we seem to break out of this loop immediately. It seems to be that file iter is returning 0 to abort the iteration. And that shouldn't be happening unless the name is the same. However, I have to compare the return value of string compared to 0. So yes, that is what did happen. The two names did not compare equal. And that caused the string compare to be different from 1, which caused it to abort the search on the first name. Okay, now that that's settled, I think the program should work. Alright, I have to copy my local version. I think I only modified NFS ls because I only modified the interpretation of the callbacks and already complains about should continue reading. So now we do get a file handle back. We get one file handle back from our search, and we should be able to we should be able to read from that file now. Now that we got it, we got the file handle in our search result. We no longer print the file handle, but we issue an NFS read. And by the way, Wireshark can go away. Gonna open the same file to see how I did the read. Okay, first comes the socket. And right, I'm going to specify car. I know that this file isn't bigger than this. Buffer and length. So I issue the read. The handle, the data goes to buffer, which it wants to be in a unit and why do I at any point do computation on the buffer? Not right now, so I can make this a void, and then I wouldn't have to cast. That's fine with me. So what was I going to do? Car buffer 512. We know that it is not going to be bigger. We take the sock, we take the handle, we take the buffer, we take the size of the buffer, and I want them to be close together. Then we have the file offset here. Which is going to be 0. So I issue this read. I'm on this line, these two lines. You save yours out. I really wish I could. Really wish I could have these two things updating together, but there are some issues when you use tools from the 80s. Okay, we issue the NFS read, and so it's red. And in theory, well, Well, technically we should return whether we hit the EUF or not. Yeah. Let's not. Let's keep this read API the way it is. And see how it behaves. So let's have a print up here. Red colon %s. Now, there will be more than one new line in the file, but who cares? And of course, what we have to do here is say buff of size red equals 0, since the file does not have a terminating 0. I don't think. Okay, now that we did that, we should be able to compile. This is an FD, not an NFS. I think that's that. And what else? Right now, search result dot handle. This is a dot. It's called result handle. Then the buffer, then set with the buffer, then a 0 for the offset. I don't see the issue. Oh, count is undeclared because it's no longer count. It's size. Okay, we seem to be doing a read. I see what's going on. The issue is that we do not flush the socket out. The socket to the NFS server. We need to flush it out before we issue the next call. Otherwise, the receive operation will give us a partial result from the end of the old call. So that means we either close the connection and open a new one, or we read the queue out before we start up a new deserialization. So I guess I should have a serializer a deserialize or finalize call that flushes the queue out. I think that's what I should do, deserialize or because that is what happens. Well, I guess we can just reconnect. Or upon exiting the read, we have to close and reopen the connection. You see here I'm issuing a read call over the same socket that I just issued the read dear plus from. In the case where I quit reading before I read the last byte of my result, I will get bytes from the old result and not from the new one that I just issued. So that's the problem. I'm not quite sure how I want to deal with it. I guess when I break from my should continue reading loop. Well, technically, the caller of the API shouldn't need to know. So that means I have to do that within reader plus. So there are two cases where I say I should not continue reading. One case is this one. And in this case, we just read the EOF byte. So it means there is nothing more inside this fragment. And in this case, we are quitting in the middle of an iteration. So that's the place where we have to read until there is nothing more to read. So what we do is, this feels yucky, but what we do is we say, how much do we have left? Buffer, I think it's left buffer. RPC deserializer left. Is the buffer left? Yes. Okay. How much do we have left? Flush out receive queue. Now, how much do we have left in our buffer? We do buffer left. While there is stuff left in the buffer, we want to discard everything that's in the while buffer left. And self fragment left. That's not self, right? That's D dot. So fragment left is how much we have of our reply, and that basically tells us how much we have to read to discard the rest of the answer. That would be a pH file. Fragment size left. The only thing that can reduce the fragment size left is, well, at the moment it's nothing. Well, it should be a refill buffer. A refill buffer removes the bytes it has just received from the fragments as left. There we go. So, refill buffer is a static inline in the RPC serializer C file. We cannot call that, and we should not call that from our user program. But what we can call is ensure size. And ensure size will remove will fill our buffer back up if there is less left in the buffer than we are querying for. Since we want to discard what's in the buffer while there is fragment size left, what we want to do is set the amount that is in the buffer to 0, and then we request the min of fragment size left and the full buffer size. So yeah, what we do is, first of all, we say what's the number that we have to reset? It's the buffer left number. And the way we make it seem as if we had read our whole buffer is by setting the read pointer to the buffer pointer plus buffer left. So let's do that. Read pointer equals the buffer pointer, and this, by the way, has to be cast to an int 8t. Plus buffer pointer plus buffer plus equals buffer left. This will put the pointer to the end of what is left in the buffer, which means that when we do the refill, nothing will get copied, since there is nothing left. So we will now read, whole size will be 0. We won't copy anything. Then we will receive the max buffer worth. We will remove the fragment size. We will decrease that by how much we received. We will set our size to the received bytes, and a read pointer starts at the buffer pointer location. So this means after we added buffer left to the read pointer, we should be able to assert there is nothing left in the buffer. City serializer buffer left. Then we ensure size so then we do if the fragment size that's left so max query size equals, normally it would be the max buffer size. However, if we have less left than our max query size, then set the max query size to the fragment size left. So that means when we now do a ensure size on the RPC deserializer, we should get the max query size, and after that we update buffer left. It equals I think that what we have to do, well, since we do not use buffer left to quit our loop, the only thing we use is fragment size. What we can do is get rid of this and replace this buffer left variable with a call to buffer left. Then we assert that the new buffer left is 0. We set our max query size. We remove that if it's smaller, and we do an ensure size, and after that ensure size we remove the fragment size left, which then will go to 0 at some point. So that should work out well. One. I think there is a way to fix this. Like that. Well, it doesn't crash. I am assuming that it for some reason tries to receive more than is in the socket, and it will be stuck on during the receive call. Shall we bet on that? Yes. That is the debugging. Here it queries the max buffer. Alt size is 0 as expected. Let's see how much there should be. See that? That fragment left is a negative number. And I wonder why that is. It's not a big negative number, I think. P self it's -4. I can think of reasons for that. It might be that the fragment size is smaller than the bytes received. So maybe we shouldn't loop while there is fragment size. We should loop while the int chars fragment size is greater than 0, because once it's smaller than 0, then there is no fragment left. The buffer is empty and we can go and do the rest. Okay, now we seem to be in the same situation, which is weird. Our fragment left is negative again. And we didn't even get that much data to begin with. Like the last size we received must have been 24 bytes, because that's our size. And our fragment size is negative, at least after receiving the bytes. So I don't see how could the old size have become negative? Could that be the case? I mean, that almost seems what must be the case. Let's assert that old size is greater than or equal to 0. And shall we bet that that assertion will fail? I would have lost that bet. It didn't fail. That's weird. Old size is 0. So there's nothing in the buffer. Fragment size left is negative. By the way, let's make sure that this fragments has left. Number gets interpreted as negative. So C fragment says left, and it, by the way, can't get any bigger than assigned 32-bit number can, because the last bit is used for the final. So this will be read correctly, even if it is even if we force it to be signed. And fragments has left is now shown as -4. I think we are in the loop to, oh no, we're not in the loop to remove our old stuff. We're in the NFS read. And we did read a correct header. Otherwise the assertion would have failed. But at this point in time, the read seems to fall short. It seems to have less than we expect. Less than the auth header even. That's weird. Alright, we will have to look at what actually comes in again. God bless Wireshark. Like, seriously. By the way, there's always some top thing is annoying at the current. Let's apply NFS. Yes. Stop. So the reader plus call goes in here. The reader plus reply goes in here. And after that, no more call is being made. And since no more call is being made, we wait forever to get our receive. So can it be that all that happened is that we forgot to do a send? Nope, a send is being issued. Right here. We receive the header, then we skip the auth and apparently that's our downfall. Okay. Let's disconnect from NFS for a bit. And then we will have only NFS for us. So all we capture will be something that we send out. Okay, stop. That is fairly conclusive. I do not see any connection attempt. This is interesting. When we search for that file, we were searching for this ll.txt here. It is the one where the end iter comes next. So if the next reply to the reader plus there is one, and I wonder why. Because or is that still okay? We don't have any NFS running unless we issue it ourselves. Okay. So what I see is a reader plus call that I'm issuing myself. What I don't see is a read call after that. want to see the destination is equal to the thing, and there I see a read call. I see the read call, but it's a malformed packet. I want to follow the stream where the read call is. Here is the reply. Alright. It doesn't like my credentials. Because I didn't push proper credentials. What credentials did I push when I did the call? If I can even see them, probably none. What credentials did I push for the Retail Plus? My Unix auth and Retail Plus. You can see it has a push Unix auth n before I push the dir handle. That is what I didn't do when I did the read call, and that's why the read failed. So that's something that I have to do before I push the string. I have to push the Unix auth. So now that I'm doing that, I would assume that it will work. Well, at least we didn't hang. We still failed somewhere, but we didn't hang. No, I remember where we failed. We had this one case that we didn't handle because it was too hard, and that's where we failed. Here. When the buffer left is less than the size of the array we are reading. We have to compile without optimization to see what's going on there. Like that. We have 12 things left in the buffer, and the array size is not a number. That is not a correct number. The result count is also not a correct number. That makes me wonder. whether I'm doing the right thing by reading a 64-bit number. I don't think so. Okay, now my read call is authenticated and my read reply is opaque data, and it is the file with the numbers in 653769. It isn't that big. It has a count. The count is a 32-bit number. And I'm reading a 64-bit number. And that's what gets me all hung up. Read U64. Counts that. So what happens is after the status, there is a bit that tells me whether there are file attributes. That's one. That will cause me to read these file attributes. After that, there comes a count, which is a 32-bit number. That's what I'm reading right now. Then comes an EOF that says a 1 or 0. In this case, it's 1. Then I'm reading the size of the array. That's 15, same as the count. That's correct. Then I'm checking how much there is left in the buffer. There should be 16 bytes. That is less than the 15 that I have. That is less than the 15 that I have to read. And that's that. The read worked, printf didn't, but I could look into the buffer. Well, yeah, the printf wouldn't work when. The printf wouldn't work if you don't put the name that you want to print there. Yeah, well, you have to put the buffer if you want to have the data, that's right. Well, I would say that is how success looks, because when I remount the thing, I have to do cat mount git ll txt, we should see the same exact data. Data right, 6533379, which is exactly what we see here, right here. So that's a great thing. So we did manage to implement the read. Now let's see how long we actually needed to do that. Almost 3 hours. But then again, we're doing this from scratch. Luckily with Wireshark support, without that, I think we would be in the water. But yeah, that's how it goes. I think this is it for this evening. So, see you later.